Hello friends, welcome back for today's session. I am Professor Fayaz Khawadi. Today we are going to discuss what is the velocity of sliding, the expression for finding the velocity of sliding, and these two concepts we are going to understand by solving the numerical from the units per gear in the subject theory of machine. The problem statement is that a pinion with 12 centimeter pitch circle diameter meshes with a gear of 40 centimeter pitch circle diameter. The teeth are of model 2 mm and pressure angle of 25 degree. If addendum of each wheel is 6 mm, assume pinion is a driver and it rotates at 200 revolutions per minute. To find the velocity at the instant of contact. That is, you have to find out the velocity of sliding at the point of engagement. Second, at the point of disengagement. And third one, at pitch point, you have to find out the velocity of sliding. That is the problem statement. For this, first we have to understand what is the velocity of sliding of machine teeth or machine gear. It is defined as the velocity of one tooth relative to its matting tooth along common tangent TT at the point of contact. So again, I am referring the previous figure that we have already studied in the previous YouTube channel regarding law of gearing. In brief, I again explain that figure. Let this is the gear 1 having center O1 and it is rotating with uniform angular velocity omega 1 by anti-clockwise direction. At the same time, the gear 2 is meshed with the teeth of gear 1 and it is rotating with angular velocity omega 2 and it is having center O2. A is the point of contact and P is pitch point of contact of two matting teeth. TT is the common tangent passing through point of contact and NN is common normal which is again passing through point of contact. Now the velocity of point A, which is on gear 1, that A point is common tangent point on both the gears O1 and O2. Okay. Now the velocity of point A with respect to gear 1 along common tangent TT. We have to find out the velocity of point A along common tangent line TT. See, V1 is the velocity of point A on gear 1. Okay. And velocity of that same point A on gear 2 is V2, where V1 and V2 are the linear velocity of point A on gear 1 and gear 2 respectively. Now we have to find out the velocity of point A along common TT line, along common tangent line. So for that I am considering the triangle ADE, because we have to find out the velocity of A along common tangent line. That means along common tangent line is parallel line to DE. So we have to find out the velocity of A along DE, along DE. So we have to find out DE. So I am considering the triangle ADE. This is a right angle triangle because DE line is perpendicular to AC. AC. So it is 90 degree. ADE is 90-degree angle. Angle DAE. DAE is angle alpha. Okay, so we have to find out DE. I am taking the relation of trigonometric relation of sine A. Sine A is equal to DE divided by V1. Sine alpha is equal to opposite side divided by hypotenuse. So DE divided by AE, and AE is nothing but V1. So DE will become here V1 sine of alpha. So velocity of point A with respect to gear 1 along common tangent TT is DE. So DE is equal to V1 sine alpha. Now the velocity of same point A with respect to gear 2 along common tangent line TT is df up to here. Velocity of point A along common tangent line is df. So I am considering the triangle ADF. ADF. So again, angle ADF is 90 degree and angle DAF is theta. Theta. This angle I am considering, this angle is theta. So this angle again it will become theta. So I am considering the sine relationship of alpha, trigonometric relation. Sine alpha is equal to df divided by v2. Sine alpha is opposite side divided by hypotenuse. So df will become v2 sine theta. So the velocity of point A with respect to gear 2 along common tangent line TT, that is nothing but df, parallel to TT is df. So df is equal to v2 sine theta. v2 sine theta is equal to df. Now the velocity of sliding of gear 1 with respect to gear 2 along common tangent line is given by vs. Velocity of sliding is equal to dE, this dE minus df. Velocity of point A with respect to gear 2, velocity of sliding of gear 1 with respect to gear 2 is Fe. And how that Fe is getting? dE minus df. dE minus df. So what is dE? dE is equal to V1 sine alpha. dE is equal to V1 sine alpha minus df is equal to V2 sine theta. V2 sine theta, as we discussed in previous slide. Okay. Now putting the values of V1. What is velocity? Linear velocity. In first year engineering mechanics, we have already studied the linear velocity of rotating point is equal to r into omega. R is equal to radius of curvature, and where omega is equal to angular velocity, omega. Okay, angular v is equal to r into omega. Now putting the value of v in terms of r into omega. So Vs is equal to omega 1. V1 is nothing but omega 1 into a radius. A radius of gear 1 is equal to O1A, this dotted line. O1A. Okay. R into omega, this R, AO1. R into omega 1. Omega 1. into sine alpha minus again V2 is equal to omega 2 into O2A. This is radius R into omega 2. So R is nothing but O2A, O2A into omega 2 into sine of theta. But from triangle O1CA, O1CA, this triangle, O1CA, sine alpha is equal to AC divided by O1A. Again, this angle is 90 degree. So applying trigonometric relation here, sine alpha, this angle is alpha. So sine alpha is equal to opposite side AC divided by hypotenuse O1A in this triangle O1A, and same applying for O2. If from triangle O2BA we are considering O2BA, again we are considering this triangle in which there is a point of contact A. Okay, so O2BA, we are considering this triangle O2BA, sine theta is equal to AB divided by O2A, this is radius O2A. In this triangle, opposite side AB divided by hypotenuse AO2, AO2. So putting the values of sine alpha and sine theta in this equation, velocity of sliding equation. Okay, so velocity of sliding is equal to omega 1 into O21 O1A, this omega 1 into O1A into value of sine alpha, this value of sine alpha from this triangle is equal to AC divided by O1A, AC divided by O1A minus omega 2 into O2A, omega 2 into O2A into sine alpha, putting the value of sine alpha from this equation, sine theta is equal to AB divided by O2A, AB divided by O2A. From this equation, O1A and this O1A will cancel each other, and O2A and this O2A will cancel each other. So equation will become is equal to velocity of sliding is equal to omega 1 into AC minus omega 2 into AB. See this, omega 1 into AC minus omega 2 into AB. But what is AC? AC. AC. Again, we are considering this length in which there is point of contact. AC. AC is equal to AP plus PC. Omega 1 AC is equal to AP plus PC. See here, AP plus PC in this figure. Okay, and what is AB? AB. AB. Again, we are considering BP minus AP. AB is equal to BP minus AP. AP is AP. Okay, BP minus AP. So omega multiplication of omega 1 into this bracket, and again next step is multiplication of omega 2 of to this bracket. So omega 1 into AP plus omega 1 into PC minus omega 2 into BP, omega 2 BP, and this minus minus will become here plus omega 2 AP. Okay, so AP is common here. So I am taking from this term omega 1 AP and omega 2 AP. From this term I am taking AP common into omega 1 plus omega 2. Okay, plus remaining terms omega 1 PC minus omega 2 BP. But as per law of gearing, as per law of gearing that we have already discussed in previous session, the what is law of gearing? If you don't remember, I will show you here in law of gearing. We have already derived that formula, omega 1 divided by omega 2, angular velocity ratio, omega 1 speed of driver to the speed of v1 is equal to O2b divided by O1c is equal to O2p divided by O1p is equal to Bp divided by Cp. So we are considering this relationship, omega 1 by omega 2 is equal to O2p by O1p is equal to Bp by Cp. That we have already derived that formula in log gearing session. So from this we are considering this term and this term for further analysis. Okay, omega 1 divided by omega 2 is equal to O2p divided by O1p is equal to Bp by Cp. Now considering this term and this term, omega 1 by omega 2 is equal to Bp by Cp. So cross multiply omega 1 into Cp, omega 1 into Cp is equal to omega 2 into Bp, B2. So putting the value of omega 1 Pc in this equation, okay. So the equation will become velocity of sliding is equal to AP into omega 1 plus omega 2 plus this value, omega 2 into Bp, here putting here, minus omega 2 Bp. This plus and this minus will just cancel to each other. The remaining term will be Vs is equal to AP into omega 1 plus omega 2. So velocity of sliding is directly proportional to distance of the point of contact from pitch point. Velocity of sliding is directly proportional to distance of point of contact. This is point of contact A at particular instant from the pitch point. A from the pitch point, P is the pitch point. So this distance AP, velocity of sliding is directly proportional to AP. AP. P is the pitch point and A is the point of contact at particular interval, at particular location, at particular rotation. Okay. In other words, we can say that the velocity of contact is the product of this product. Now, sum of angular velocities omega 1 plus omega 2, angular velocities of two gear and the distance of point of contact from pitch point. The distance of point of contact A up to the pitch point AP. So velocity of sliding will become AP into sum of angular velocities. So velocity of contact will be product of AP into angular velocities, sum of angular velocities. Clear? Now come to our actual problem in which diameter is given 12 centimeter, that is nothing but 120 mm, and the another diameter is given 40 centimeter, that means this is gear and this will become pinion, smaller diameter is pinion. Okay, so diameter of gear is 400 mm and pitch circle diameter of pinion is 120 mm. Module is given 2 mm, pressure angle is 25 degree, addendum is given 6 mm and the rotation of gear 1 is given 200 revolutions per minute of gear 1, that is rotation of pinion is given 200 revolutions per minute. So from this we have formula to find out the angular velocity is nothing but omega is equal to 2 pi n upon 60. Okay, so 2 pi n1 upon 60, it will become 20.94 radian per second. So angular velocity of pinion will become 20.94 radian per second. Now we have to find out the velocity of instant of contact. That means at 3 locations we have to find out velocity of sliding. Okay, so solution we are discussing now. The radius of addendum circle of pinion is, what is the radius of addendum circle? Pitch circle radius plus addendum. That will become addendum circle radius for pinion. So I am using small r suffix a. So if 120 mm is the diameter, 120 mm is the diameter, pitch circle diameter. So radius will become 60, half of 120. 60 plus addendum is equal to become 66 mm. So radius of addendum of gear. So capital R suffix a is capital R, pitch circle radius of gear, which is given 400 is the diameter of pinion, sorry, gear. So radius will become 200 plus addendum is 206 mm. Length of path of recess PE, as we discussed in previous slide, by using the formula for length of path of contact. If you remember, I show you PE, length of path of recess. Length of path of recess, this is the formula as we discussed in previous session. PE is equal to under root small r a bracket square minus r square cos square phi minus r sin phi. That is the formula for to find out length of path of recess PE. From this formula, we will find the path of recess PE. Okay, that answer we are getting here 12.04 mm. Okay. And length of path of approach FP, length of path of approach. See here, length of path of approach FP is equal to under root capital R A square addendum circle radius of gear minus capital R square cos square phi. That radius is circle radius for gear. That is under root. Then out of that root is minus capital R sin phi. That is capital R is circle radius of gear again and sine of pressure angle. From this formula, we will find out path of approach. So we got here the value of path of approach is 13.35 mm. Okay, here now velocity ratio. In previous session, the gear ratio or velocity ratio, we have already discussed that what is gear ratio or velocity ratio. It is the ratio of speed of driver to the speed of driven. Speed of driver wheel to the speed of driven wheel. See here in the terminology of spur gear, terminology is spur gear. We have studied that gear ratio is speed of driver to the speed of driven is equal to, it is in angular velocity, this is linear velocity, revolutions per minute. So omega 1 by omega 2 is equal to diameter of driven to the diameter of driver is equal to number of teeth on driven wheel to the number of teeth on driver wheel, T2 by T1. So we are considering this relation omega 1 by omega 2 is equal to D2 by T1, where D2 is gear and D1 is pinion. So where D2 is gear and D1 is pinion. So instead of taking the relationship of diameter, I am taking the relation of radius. Omega 1 by omega 2 is equal to capital R divided by small r. So we have the value of omega 1. Omega 1 that we got here 20.94. So we have to find out omega 2. So omega 2 will become omega 1 into r by cross multiplication divided by capital R. Capital R is given 200 in previous slide. 200. This is 200. Okay. So 60 into 20.94 divided by 200. The answer is 6.28 radian per second. Omega 2 will be 6.28 radian per second. Now we have to actually find out the velocity of sliding. The velocity of sliding at each point of engagement, that point of engagement is F. If this is rotating by clockwise direction, pinion is rotating by clockwise direction and gear is rotating by anti-clockwise direction, F will become point of engagement and E will become point of disengagement. F will become point of engagement and E will become point of disengagement for this gear pair and for this gear pair, which is same. And P is the pitch point. So what is our formula of velocity of sliding? Velocity of sliding is the summation of angular velocities omega 1 and omega 2 into distance of point of contact up to the pitch point. So Fp, okay, so Fp into omega 1 by omega 2. So Fp, the value of Fp, that is nothing but path of approach. The value of path of approach by Fp's formula is getting 13.35 into omega 1 plus omega 2. So the answer of velocity of sliding at the point of engagement will become 363.61 mm per second. Velocity of sliding, so unit will become mm per second. Second one, the velocity of sliding at the point of disengagement. That point is disengagement E. Okay, so product of summation of angular velocities omega 1 and omega 2 into EP, distance of point of contact up to pitch point, this EP. Okay, EP will become here the value, this EP is path of recess. So we got the value of path of recess is 12.04 into omega 1 plus omega 2. So velocity of sliding at the point of disengagement is 327.97 mm per second. Now the velocity of sliding at pitch point P, pitch point. So velocity of sliding will become product of summation of angular velocities omega 1 plus omega 2 into distance of point of contact and pitch point. So this will become same point. Point of contact P will be P and pitch point will be P. So PP is distance 0. So whole term will become 0. Okay. So in this way we have to find out velocity of sliding at different locations, at point of engagement, at point of disengagement, and at pitch point. Okay. So this is clear to you. At the end of this session, you can understood the velocity of sliding. You can find out the velocity of sliding by understanding the expression. Okay, and after completion of this session, the student can solve the numericals on velocity of sliding. Thank you.